All right, thanks, Phil. So IPACS is an Australian technology company. We work across the mining, energy, and defense sectors. We as a company are committed 100% to safety, and that's reflected in our stats. We have 0 LTI in the last 19 years. We have 37 customers today. We work as contractors to major mining, defense, and oil and gas companies. Before starting this presentation, I thought I'd reflect on some of the key facts of the mining industry in Australia. In 2004, Australia exported roughly 230 million tons per annum. Today, Australia exports nearly 750 million tons of iron ore per annum. Most of it comes from WA. Australia is the largest exporter of coal, iron ore, lead, zinc, many other commodities. And by 2018, it's tipped to be the largest exporter of LNG in the world. The scale of growth of the mineral sector in Australia has been phenomenal. We have grown at a record pace of 12% per annum. And no doubt this growth has been supported by technological advances. What is even more interesting is that a lot of our mining operations and our projects are long-term. Look at BHP Billiton, for instance. They expect to run their operations in the Pilbara for the next 100 years. Same like Rio Tinto. BHP Billiton expect to run Olympic Dam for the next 200 years. However, it is true that in the current environment, there's a big focus on reducing cost of production. The declining commodity prices have essentially turned these mining operations into margins-based businesses. In a margins-based business, you need to try and save every dollar, and the pursuit to be the lowest cost producer is very high. And technology has played a very important role in helping these companies achieve this. Technology has delivered spectacular results to the mining industry, and there's absolutely no question about that. Take, for example, the autonomous driverless trucks, which are being used by the likes of BHP Billiton, Rio Tinto, and FMG. They've drastically reduced the operational cost. For every truck driver in the Pilbara, you typically require 5 operators. 1 day shift, 1 night shift, 1 the next swing, or 2 for the next swing, and 1 spare. Autonomous trucks immediately reduces your operational costs then, or labor costs. However, pushing automation too far is also very risky. Take, for example, Rio Tinto's autonomous railing. It has been a spectacular failure. So the question is, what next? What next in terms of technology for the mining industry? If you go back to the basics and start looking at the cost structure or budgets within any mining operation, you typically find that nearly 60 to 65% of your cost is attributed to your labor cost in maintenance or equipment downtime. And that is our story. Our story is about building technology to help companies reduce problems that arise due to equipment failure. So how do we do that? We first convert assets, or assets are basically machines which are used in the production of these minerals. So we turn these assets into smart assets by retrofitting them with a variety of different types of sensors. Now this is a type of sensor that we've recently developed. It's a wireless sensor. These sensors generate information such as temperature, pressure, vibration, and speed. We use data from these sensors to determine in real time the mechanical health of these assets. So here are some examples of machines which are used in the mining industry, and here are some examples of some sensors that we can use. So then we apply data analytics to the data that we are receiving from these sensors to help companies reduce breakdown, improve reliability, cut waste, and improve asset health. And this has been the inspiration behind a technology center that we established here in Adelaide, which we call as the Remote Operations Center. We received funding from the Department of State Development. Our partners in this project include OSIsoft, HP, and the University of South Australia. This center was launched by Honourable Tom Kustrittanos, who's the Treasurer and Minister for Mineral Resources and Energy. From this center, we help companies achieve maximum production at the lowest possible cost in the safest possible way. We believe that the keys to lowering cost and increasing production are 1, through the automation and centralization of production systems, 2, through the automation and centralization of machine health diagnostics, and 3, through de-bottlenecking of operations. So we help companies centralize their production systems using the OSI soft technology. We help companies automate and centralize machine health diagnostics using condition monitoring technology. Now, condition monitoring as a technology has been around for decades, really. Our pioneering work here, which has really arisen from our work in the defense sector, is to build industry-hardened, military standard compliant data acquisition systems. These systems can capture live vibration signatures from mobile plant and fixed plant infrastructure. Typically, vibration analysis was only restricted to fixed plant, where you take a handheld system and collect data, but with our technology, you're able to collect that data on mobile plants as well. And finally, we help companies de-bottleneck operations using predictive analytics. So in this slide, I basically illustrate what we are on about here. You could have mining operations, whether it be underground mine, open cut mine, process plant, and the data would flow in through a SCADA system. Or we could deploy our own sensors at site and capture data and then apply data analytics to provide early warnings for potential machine faults. I shall now present a few case studies. The first case study is at a high-cost iron ore mine. The aim of this project was to automate and centralize machine health diagnostics. So we started off by instrumenting a crusher. Whenever this crusher suffered from a screen bearing failure, it was causing a lot of downtime. So the traditional approach at the mine site was to use a handheld data collection system. And this has been a very old approach which is being used in some mine sites. However, the new focus was to provide continuous monitoring of all critical assets and to provide performance monitoring of maintenance crew as well. So if you, this is an example where we delivered substantial saving for the customer, where we identified for the customer a bearing fault, but the root cause of the bearing fault was an alignment issue. However, the maintenance crew at site only replaced the bearing and did not correct the alignment issue, and hence the bearing fault re-emerged just within a few days. So once again, we work with the customer to ensure that the quality of maintenance is uplifted so that these faults do not happen. So a lot of this technology that we developed was developed along with Tenix when they were around for the Anzac class frigates and for the defense force here. The second case study is with the world's largest contract miner. Once again, the aim here was to automate and centralize machine health diagnostics. We started off by targeting their planetary gearboxes. Each of these trucks is fitted with 2 planetary gearboxes, which are rebuilt every 20,000 hours at a price tag of $180,000 per rebuild. Now, the rebuild cycle of these trucks is much more suitable to Caterpillar than Thies, obviously. So they wanted to transition from time-based maintenance to condition-based maintenance, so we deployed our systems on the truck. We were able to receive live data from these trucks in our center in Adelaide. So these trucks were fitted with our boxes. They collected data during the load, haul, and dump cycle and transferred back to our base here in Adelaide over a 3G connection. This is an example where we identified for the customer a gearbox problem. So you've got a normal time waveform, you've got a time waveform with high impacting. This high impacting typically indicates that you've got a bearing fault, and you can clearly see broken gear tooth. So basically, we provide low-cost, low-risk access to specialist engineering technology or remote operation center technology. All of our engineers are level 3 ISO certified, and we received an Innovation I award back in 2014. Now, obviously, Australia presents a lot of opportunities, but there are even more opportunities outside our borders. So 3 months back, we partnered with a company to export our technology into China. So in China, we are looking at delivering this technology to resource companies, original equipment manufacturers, and service companies. Now, as we know, China is going through a massive modernization. 20 years back, the focus was on manufacturing. 10 years back, it was on construction. Now the focus, where the Chinese government is spending billions of dollars, is in creating high-tech companies. So we've already signed a deal with New Era Fire to supply nearly 25% of China's fire suppression equipment. We'll be establishing a center for remote monitoring where they'll use our sensors. So this is a slide of a presentation that I gave to the Chinese government a couple of weeks back. So these are the types of equipment that will be available at sites. We've retrofit these equipment with a variety of different types of sensors of our own. Data from these sensors will come into our center here in Adelaide. We'll provide the analytics and finally deliver the reports back to the engineers on mobile phones. We've signed a memorandum of understanding for a joint venture with Hangzhou Smart Bridge Information Technology. So Hangzhou is going to be the next, or the Chinese government wants to make it the next high-tech capital in China. That was where the G20 was last held as well. We are in advanced discussions in setting up similar operations in India as well. We are discussing with one of India's largest state-owned mining companies. Sam Walsh, who recently retired as the chief executive officer of Rio Tinto, said that remote operation centers are completely changing the face of modern mining. This is the reality. But what is also the reality is that you're going to see a transition away from automation or heavy automation into more predictive analytics and machine diagnostics and maintenance to deliver lower cost production. And this is essentially our story. Thank you.
Thanks, Vinay. It's fantastic to see what the application of some of the STEM issues in South Australia, how they come into the companies and what that can mean for us in developing businesses.